right, that looks good. There you go. All right, very good. All right. A little bit late. Sorry about that. But we have not a full lesson tonight, anyways. So officially, today's Monday, not tomorrow. Wednesday this week, exam 3. March. No, April 2nd. So gonna finish up our trig unit tonight. Hopefully you watched the video. I checked the homework. About half of us started it. Of that, almost everyone who started it had a 77 or above. So I'm assuming the video went well. It's kind of awkward on it. It's been a while since I recorded a video in that sense. I'm probably always that awkward, but it's all good. So if you haven't watched this might feel like a lot, but hopefully you did and just haven't attacked the homework. The due date on the homework is this Thursday. The due date on this homework is, oh, I'd say Thursday, is Wednesday, but this one will be due next week. But I would suggest get this done as well so you're ready for the test or exam, I should say, on Wednesday. All right, so sinusoidal functions basically are sine or cosine graphs because a sine graph is a cosine graph just shifted in a direction or another. And let's just kind of review a couple things about them before diving into this, just to make sure, since I haven't seen you in person. All right, so first of all, this should be completely symmetrical, like as much of it, as it is above, it should be below. Looks like my valley is a little bit too wide there, so I'll make it a little more symmetrical. All right, that's pretty good. All right, tell me some of the things you know about this graph. Anything? Yeah. All right, cool. So this part right here, we refer to as the crest. And this part down here is the trough. Next. It is a sine graph for sure. How do you know it's a sine graph, not a cosine graph? Yeah, so a big thing, and this is going to play a role tonight. Basically, we're starting a crest at the origin. So this is all day and night sine. Cool. What else? It has an amplitude of 1. All right. So this right here is the amplitude. Now, you said it was 1. I would have to tell you a little more information, but I will let you know that this height is 1 and this minimum height over here is -1. So both of those are your amplitude. Well, when I say both of those, I mean both of those distances from this middle to the min or the middle to the max value is called your amplitude. So really, it's actually like right here, this distance and this distance. I said something else there, middle. We actually call it the midline. And what else? Anything else we're missing? Kind of a big one here. One more thing. The period, yeah. So the distance from crest to trough is called your period. which as long as I tell you this is 2 pi, then it's 2 pi. So those are the main ideas. If I'm missing something, it's in the video for sure. We're back. Hopefully, have watched that video, have these things in touch. And then we can transform this. So if I like stretch the graph vertically, then the amplitude is going to change. So going back to like exam 1 topic in this class, transformations, vertically stretch. So basically on a sine wave or even a cosine wave, you're taking the max and min values and just stretching them further from their center. Speaking of stretching or shrinking, we can do it horizontally. So this period of 2 pi can be stretched. So instead of crest, trough in a distance of 2 pi, we can make it whatever the heck we want. Out further, that would be a stretch. Inwards would be a shrink. And then we could shift this graph both up, down, and left, right, and we will do probably all of that in tonight's lesson. So moving right ahead, a cosine graph, just not to go through all of this, has all the same characteristics except that it does not start at its crest, right? I don't even really use the word crest and troughs with cosine graphs, but I am right now, but I probably won't anymore. This is like half of a crest, so it's like it started over there. And that's what I mean. Every cosine graph, right? So let me back this up a little bit. It's like if I could extend this backwards a little bit, then I would say, oh, there is a crest followed by a trough. And so that looks just like a sine graph, except it's been shifted backwards. So that's why we say both sine and cosine graphs are called sinusoids, because they do have the same shape, just one is shifted, a shifted version of the other. But the main thing here is to recognize that it's starting at its max value. And so all day and night, we want to associate that with cosine. And that's really the big thing. All of this, but really the starting values, like sine versus cosine, right? And you'll see that. Does everyone have a piece of paper? Yeah, cool. All right. So this is all we have to get through tonight. Modeling with sinusoidal functions. So write an equation of the form y equals a times cosine b times a group of x minus c that has an amplitude of 8, a period of 2 pi divided by 7, and a phase shift of 8. This multiplier right there is your amplitude. So if we're told amplitude has to be 8, then A could be either 8 or negative 8. That vertical stretch factor, what I said about just a few minutes ago, to take your max or your min value higher than 1 or lower than negative 1, that multiplier up front is what's going to change that. So is it positive or negative 8? Well, it turns out there's, reading through what's here, there's no more context. So either one, choose. Me personally, I like positive 8 when possible. But you'll see in a future example, we won't have a choice, all right? But right now, just want to recognize that we could put either 8 or negative 8 as that multiplier, and both would be an acceptable answer. A period of 2 pi. Hello. Why did this just freeze on me? Okay, that's too bad. Really? What's the formula for period? 2 pi over b. Yes, that was also in the video. All right. Weird thing sometimes. So your b, that inside multiplier, is what's going to stretch or shrink your period. So the formula to know, this is a must know, 2 pi over b is your period. Well, we're told it has to be 2 pi over 7. And so now we got an equation to solve, although I think I already solved it just by looking at it. 2 pi divided by something has to equal 2 pi divided by 7. B has to be 7. But if it wasn't that obvious, you would cross multiply. 2 pi times b equals 2 pi times 7. Well, that's 14 pi. And then we would divide by 2 pi, divide by 2 pi, and ultimately get that b. Your pi's cancel out. 14 divided by 2 is 7. And then phase shift is what we call your horizontal shift. This is your phase shift value. So that's a matter of just kind of knowing that. Well, I guess all of this is a kind of a matter of knowing it. Your amplitude is your outside multiplier. Your period is affected by your inside multiplier, 2 pi over b, what to know. And that your phase shift is your inside shift. So in this case, there's not much more to know except that c has to equal pi divided by 8. So at the end of the day, when you see a question like this in your homework, it's as simple as typing in y equals 8 or negative 8. I'm going to go with 8. Cosine, parentheses, b, parentheses, x minus pi over 8. Close parentheses, and you're done. I'm going to come back to this question in just a minute because this next question has a subtle difference. It might look the same. It's not the sine and cosine, by the way. Has a subtle difference. So we'll come back to this in about 5 minutes once we go through this next question, right? Write an equation of the form y equals a sine bx minus c. That should say and has, not has, and has an amplitude of 12, a period of 5, and a phase shift of negative 3. So again, amplitude of 12 just means our a value could be either 12 or negative 12. Reading through this again, there's really no restriction, so I guess I got a choice. I'll go with 12. Period of 5, 2 pi over b has to equal 5. I'll put this over 1, cross multiply, divide by 5, and b will be 2 pi over 5. Now, our phase shift of negative 3. So this is sneaky. And I didn't like this in the homework, but it is what it is. Our phase shift is negative 3. I'm going to say that C is -3. Circle it. But here's what I said we're going to come back to something in a minute. Let me write this exactly as it states. Y equals A sine bx minus c. And I'm going to tell you what's going to be marked wrong. This would be marked wrong. So that's why I don't know how to say this without just doing it. If you wrote 12 sine 2 pi over 5 x minus -3, that would be marked wrong. Not because this is a double negative. Even if you change that to +3, this would be marked wrong. So this is wrong. This is the same thing, just simplified. Wrong. Anyone know why? I think I discussed this in the video.
Because your B value is not outside of parentheses.
Yeah, so that phase shift is sneaky in this question. All right, I'll wrap this up. You're like, what the hell's going on? I'll wrap it up in a minute. Here's something I want to say. This is true. Amplitude, whether it's sine or cosine, doesn't matter. That's going to change your period. And when you have a second group, when it's factored inside, then this is your phase shift, like our first example. That's your amplitude. That changes the period, 2 pi over b. If you have a second group, then what's inside that is your phase shift. So the way we fix this to get the right answer is we're going to say A is 12, B is 2 pi over 5, and we're going to put a parentheses and then write x minus -3. This is good. There's your thing. There's your phase shift. Okay. And now we're going to distribute and clean everything up. This would not be marked wrong, but it wouldn't be marked incorrect. It would just say can't yet be, like, needs to be simplified. Right? So inside here, we're going to distribute the 2 pi over 5, and we're going to change this to a plus symbol, and we're going to distribute the 2 pi over 5. So y equals 12 sine parentheses 2 pi over 5x plus 6 pi over 5. And that's your final answer. All this comes down to is paying attention to what the question wants and whether or not you distribute or not. So let's step back. 100% takeaway. Outside multiplier is amplitude. Inside multiplier needs to know 2 pi over b. That's the same in both. But your phase shift requires you to open a new parentheses and put that phase shift in its own kind of grouping symbols. And then this question says, leave it alone. How do I know? Because it says it. It says, don't distribute. It says, type in your answer so that you have your inner group. And I made a teacher's note when you do your homework, because you're going to go home and forget this. I say, do not distribute. Just type it in and you're done. And you got a couple of those where it says, that's the directions. But then later, another question pops up and it's like, hey, Here's some information, write this. And it's kind of sneaky because if you're just quick, you wouldn't have recognized they wanted you to distribute here. How did I know they wanted you to distribute? Do you see an inside grouping symbol here? No. Right. But I made a teacher's note. On this one, you must distribute. So the way you do it, you still set it up like the one above. Okay? Don't just throw your C value right there and call it a day. It's going to be marked wrong. You still set it up with your inner group, and then you just distribute it through. Does that kind of make sense? You see? All right. Hopefully. Yeah. And that's your first 4 homework questions out of 10. Good. So at the end of the day, A, amplitude. Whether this is sine or cosine really doesn't matter. The problem will tell you. Period. 2 pi over b. Need to know that. Definitely, definitely, definitely. X minus c. This would be your phase shift. And plus d. That's your midline. Those are the 4 transformations to know, right? Secondly, like always use this. This is like the cookie cutter. I always do this. Then it's just a matter of, okay, does the author of the question want me to distribute or not? And the answer to that comes from looking at what they asked for. No, do not distribute. Keep it as a group inside of a group. That's your answer. Yes, distribute, because there's no inner group. Okay. All right, moving onwards. Observe this graph below. And we're going to write an equation. Actually, we're going to write 3 equations for the same darn graph. So we'll start with what's asked first. An equation of the form y equals a times sine bx minus c. By the way, we do have to distribute at the end. Just kind of recognizing that. That's what this says. Plus d, where a is less than 0. Oh, and we need to have a negative a value. Our amplitude must be negative. All right, well, before we even dive into that, what is the amplitude on this graph? 60. Awesome. And so you can get that from here to the middle is a distance of 60, and the middle to here is also a distance of 60. So there we go. We know our amplitude is 60. Go away. Okay. If our amplitude is 60, that must mean our midline is right at 0, which it is. Right? Halfway between 60 and negative 60 is 0. All right. What is the period? It's just pi, just pi. So we're starting here. We're ending right there. We're ending at pi. So I'll do that kind of over here. 2 pi over b is just pi. So if I multiply by b and then divide by pi, I can see the answer is 2. Now we're just going to do a little bit of thinking. Parent sine function. Crest, trough. That's a must know. However, if there's a -1 in front of it, how does the parent change? It doesn't go crest trough. Instead, it goes trough followed by a crest, because an outside multiplier, let's go back to parabolas, they open up if your a value is positive, and if they're negative, they've been reflected. So the parabola would open down. Well, same thing here. We have an a value of 1, so that's what it does. And if you hit it with a -1, it's just been reflected. Why did I bring that up right here? Find an equation for a sine graph where your a value is negative. So I'm going to go detective style here, and I'm going to look at what's given to me, and I'm going to try to find a trough followed by a crest. How come? Because the directions say your a value has to be negative. Are you following? Right? So it's not obnoxious. It's literally staring me at the face. Right here. Here's a trough. Here's the start of a trough followed by a crest. My question to you is, has that been shifted at all, or is that still at the origin? It's still at the origin. So for this question, the phase shift is 0. We're not shifting it at all. And then we just put in everything else we just found. Y equals -60, because the amplitude, as I said in the opening examples, we had choices, could be positive or negative a values. This is telling me, bro, it has to be negative. Okay, so -60 sine, put in my b value, put in my phase shift. Even though it's a waste of ink, I'm doing it for completeness. And then put in my midline. So everything we found up there and this specific value. Now we need to clean that up, but everything's in its spot. How do I know I got to clean it up? Because it says no grouping symbols. So my final answer looks like this. Y equals -60 sine, distribute the 2. Distribute the 2, it turns to 0. Subtracting 0 is a waste of time, so we can just close that. And adding 0 is also a waste of time. This is the simplest form final answer of that graph. Find an equation very similar, a sine bx minus c plus d. However, this time a has to be greater than 0. So here's what I need to know. If A is greater than 0, I'm looking for a trough followed by a crest. Basically, I'm looking for the start of a trough. That is not the start of a trough. My bad. Yes, it is. That is not the start of a crest. I'm looking for the start of a crest. If it's not here, then there must be a phase shift. Get my logic? If it's not at the origin, then it's been shifted somewhere. So, oh, there it is. It's a little not lined up, but pretend that's right at pi over 2. I try to get it as best I could, but it's supposed to be at pi over 2. So it's now starting at pi over 2, which means if you're not catching it, and this way if you need to watch it again at home, boom, this is the start of a crest, pi over 2. Other than that, we put back everything else we need. Find the equation. We want an amplitude that's positive, 60. Our B value is still 2. But we do have a phase shift of pi over 2. Our midline is still 0. So I really like doing these for a variety of reasons. One, because I can, but two, they emphasize to students that there literally are infinite ways to come up with that graph. I'm not going to do it, but if you're super curious, because I was curious as a learner, when you have some time tonight, really quickly, just go to Desmos, type in this equation and what we're about to simplify, and you're going to see the two graphs overlap. You're going to see the two graphs make exactly what's on our paper right there. Okay. However, all I do want to do is just now clean this up. So distribute the 2, get rid of this invisible plus 0. Our final answer looks like 60 sine 2x minus pi and as I said, if you were curious, type those both in the Desmos, the two graphs will overlap. And to further emphasize that every sine wave is also a cosine wave, let's write a cosine function for the same graph. What do I need to know about cosine? Well, it starts at its maximum. Great. It starts at its max. It ends at its max. That came out really ugly. What about negative cosine then? Well, if you're starting at your max, but you reflect it, you're starting at your min and ending at your minimum. So a negative cosine would look like that. Those are the last 4 things you really need to know from tonight's lesson. If you came in having last video lesson ready to go, all I really need you to take away tonight is kind of emphasize a sine with a positive A value, like the parent, starts at its crest. A negative starts at its trough. If it's at the origin, there's no phase shift. If it's not at the origin, there's a phase shift, and you just find it. Cosine starts at its max, ends at its max. Negative cosine starts at its minimum, ends at its minimum. Those are the biggest takeaways from tonight. And if you're asked for a cosine, but the max and the min is not on the y-axis, then there's a phase shift. There's a C value. And we've practiced 2 opening examples. We've practiced 2 here. I'm gonna do another one right now. We want the amplitude, we want the A value to be positive. So we're looking for a maximum. We're looking for a maximum. Right there. Start at this point, which is in the middle of pi over 2 and pi. What's in the middle of half and a whole? 3/4. 3/4. That's one way to answer that. Now, if you're like, I wouldn't have thought of that on a test, here's how you find the middle. So we had pi over 2. It ended at pi. And then you divide that by 2. You average, if you're wondering where I got those values from, if I'm like, yo, what is this point right here? Like, if you're wondering why I'm even doing what I'm doing, I'm trying to figure out the phase shift. So I'm like, yo, what is this? Well, it's in the middle of pi over 2 and pi. It has to be in the middle there. And so if you need the middle of something, first of all, was there an obvious answer? And that's why I said, what's in the middle of half and a whole? 3/4. So I know the answer is going to come out to be 3 pi over 4. But if you were like, I need a more concrete way, because what if they were ugly numbers? Then you just average the 2 numbers. So pi over 2 plus pi over 2. Trust me, if you put this in a calculator, makes 3 pi over 4. Right. Just put that in, and you will get 3 pi over 4. Or you can do the fraction work, and it'll work out too. So that's our phase shift. I know some of you are down on me, so I'll do it really quick. This commercial break presented by the calculator I recommended. There you go. Okay, so y equals positive A, amplitude 60. Cosine. Eve, again, here's where I was saying it's kind of sneaky, it's tricky. I don't like it, but okay, so I period, I don't like it. I wish they didn't write this online, but they do. So I'm just going to suggest we write what we know. 60 cosine, period. The B value is 2. Use another parentheses. X minus your phase shift. Plus 0, just for completeness. But then I go back and say, oh, they want me to distribute the 2. They don't want an inner grouping. Okay, so the only thing I wish the authors didn't do was call that C, because it's deceiving. It's really not C, but okay. 60 cosine 2x minus 6 pi on top of 4. Reduce that down. 3 pi on top of 2. Here's your answer. All right. Writing a sinusoidal function can be done in infinite number of ways. You can use a sine with a negative value. You can use a sine with a positive value. You can use a cosine with a positive. If we really wanted to spend 10 more hours, we could come up with 2,000 more same equations. What's up?
So I did 3.35 or 4.
Mm-hmm.
When I see like what's half like between whatever, you know where you got that. So I would put 1.55 to 2. I get that wrong.
Probably not. So if you decimals, although there may be an example, I doubt it, but there may be an example where it came out to be like 2/7, and then that's not a nice decimal. But if it's certain nice decimals, I'm pretty sure, yeah, 1.5 would be all right. All right, let's give it one more go, and then one kind of application. So if you didn't catch the vibe from that last one, here's why I'm doing it one more time. So we can do it a little bit quickly or quicker. And basically, if you didn't figure it out, the amplitude, besides positive or negative, the actual value is going to be the same. The B value stays the same. The midline stays the same. It just matters whether or not we're using a positive sign, a negative sign, a positive cosine, or negative cosine. And that's going to change our phase shift, right? So basically, if we can find the amplitude of midline and the B value, we have most of what we need. So see if you can do that right now based on what you're looking at. What's the midline? What's the amplitude? And what's the period? Actually, I'm going to add what, it's not just what's the period, but find the B value. All right. Midline 6. 2 ways of getting it. And this was a previous test question, so I copied and pasted it for you. I don't make like obnoxious numbers. It should all be visual. I think that's how we learn. But if you're a formula-based person, there is a formula for it, okay? So you take your max and your min values and average them. So find your max 9, and that's just comes by looking anyways. 3 makes 12, divided by 2 is 6. In the middle is 6. Amplitude, again, once you kind of mark up your graph, you should be able to visually just count it. From 6 to 9 is 3. From 6 down to 3 is a distance of 3. And it confirms you have the right amplitude. But for the formula-based people, I promise you I don't put obnoxious numbers on tests. Some of us just learn that way. There's a connection. Max minus your min, it gives you amplitude. And then period. So we're kind of just looking at a lot of different things, but hopefully we notice, there's a lot of things to notice, but starting here at 0, I'm seeing a trough followed by a crest. I know that's 1 period. So when I look down, I'm like, oh, it's not 2 pi, it's 3 pi. That's it. It's how long it took to complete this cycle. So the period, the answer to that question is 3 pi. Now, what's the b value? What's the transformation value? 2 pi over b equals 3 pi. Cross multiply, divide by 3 pi, and you get that b is 2/3. Right. From there, let's see what we need to answer. Find an equation, find a sine equation, and a has to be positive. And at the end of the day, clean up your inside. All right. If a is positive, I'm looking for a crest followed by a trough. So I'm going to put that midline back in really quickly. Just reminding you, all right, so here's what my brain's thinking. That's a positive a value. I want a crest followed by a trough. So boom, right here. Here's the start of a crest followed by a trough. It is not starting on the y-axis. It is starting at 3 pi divided by 2 to the right. So our phase shift is 3 pi divided by 2. Other than that, you just smack all our pieces in here. Positive amplitude, which was 3. Sine. B value is 2/3. Always use kind of wrap this up. Always use a inner parentheses ourselves as we write these things, okay? And then, I know I said it 5 times, but I'll say it 6 times. Just go back. Does the question want us to distribute? Yes, it does. There's no inner grouping. So final answer, y equals 3 sine 2/3 x. And then this would be 6 pi on top of 6. So that just simplifies to pi. And the plus 6 at the end, representing our midline. Find a cosine equation where a is negative. Again, just to remind us, even though I said it a few times, you're leaving tonight knowing cosine goes max to max. And that negative cosine goes from min to min. So we're looking for a minimum. Right there. There's a minimum. It's not starting on the y-axis. It's been shifted over 3 pi over 4. So it says negative amplitude, which means we're starting at a minimum. Just make sure you write your negative in your final answer. Six on top of 12. So that's 1 on top of a 2. That would be your distributed answer. All right. So we started tonight kind of just looking at the facts. If you have amplitude and phase shift and midline and things like that, they just fall into certain spots. The middle part was, hey, here's a graph. Well, grab the amplitude, grab the phase shifts, grab whatever you need, put them into their spots. The last part is an application problem where we have to interpret what the parts mean and maybe build a quick sketch of a graph. This is where exam 3 terminates. Last question. So here's a function h of t, which gives the height of a seat on a Ferris wheel. The height is recorded in feet. And the input is a unit of time, specifically seconds. So the way we should interpret this, the way we should train our brains to think about this, is since we have a cosine function, regardless of all the other transformations, is that this thing is just eventually starting at a max, going to a min, going back to a max, to a min, over and over again, going around a Ferris wheel. The heights, you're eventually at the top, then you're at the bottom, then you're at the top again, then you're at the bottom, depending on how many times you go around this damn thing. I'm good with once. I'm good with none. I don't really like those things. So boring. But anyways, now I'm going to dig a little deeper. I notice I have a negative 80 out front, and I notice it's a cosine graph. So I'm going to start just sketching this. Here's time. Here's height. And the fact that it's a negative cosine, I know it's starting at its minimum. Before I just throw that right there, I want to think about this. Is there a phase shift? So I'm looking inside here and I'm wondering, is there any shifts going on here? Nope. And before I just throw a negative 80 right here, since there's no shifts, I got to pay attention to this midline of 90. How would I build a quickish sketch of this graph? Here's my strategy. I just did step 1. Digest it. Haven't done anything yet, but just kind of think roughly what I'm about to do. I don't really need a phase shift. I'm going to be starting at a negative value. but there is a midline of 90. When you take calculus, this is about as much as you need. Start a midline. So I'm starting at 90. And from there, we're going to go down 80. So I probably should redraw this first of all. Now I'm like thinking, this isn't good enough. I think I'm just going to do this. Here's my 90. I'm going to go how much up and down? 80, because the amplitude is 80. So if you're at 90 and you go up 80, what's your maximum? 170. If you're at 90 and you go down 80, what's your minimum? I'm going to work this. 2 pi. I'm not finding b. We have b over 15 pi is your period. 2 pi over b is your period. So 2/15 is your period.
Can you repeat that?
2 pi over b is the formula for period.
I was about to
The
ask
b
where
value,
pi came from, but now
the b value is 15 pi. So we're not, everything tonight we've been finding b. This time we're substituting it in. It's right there. We're not finding that value. And since there's no phase shift, this is going something like that. There's a quick sketch of that graph using the key features. Start with the midline. This is my strategy. Because from there, I know how much I'm going to go up or down. Then I go to the inside stuff. I figure out the period using the formula. And if there's a phase shift, that's where you're going to start. Well, on a negative cosine graph, that's where I would have started the minimum value. But there isn't a phase shift, so I know it's starting right there. Part A. How high does a seat on the Ferris wheel go? 170. How close to the ground does it go? Look at that. Here's where we just got to do a little bit of thinking here. If a ride lasts for 8 minutes, how many times does a passenger go around? So this is one time around. 2/15 is what unit? Seconds. (2/15) is in seconds. This ride goes for 8 minutes. How do we answer that? What's up? Okay, so you want to turn the minutes into seconds. I'm with you. All right, so I'll go that way. So biggest thing to notice is there's 2 different units of time here. This is in minutes. So 8 minutes. call me silly, but I really have to do like this way. 60 seconds is 1 minute. I have to use my unit conversions. I always forget that. If you knew to multiply by 60, good for you. I always need to do it with labels. So 8 minutes is 480 seconds. So now we can rewrite this question. If a ride lasts for 480 seconds, how many times does a passenger go around? Well, we still got some work to do. 2 out of 15 seconds, they go 1 time around. 4 out of 15 seconds, they would go 2 times around. So basically I'm saying, how many 2/15ths make up 480? A lot. I don't know if this is a realistic Ferris wheels. This is why I don't go on these things. The thing's broken and they're probably stuck on there forever, flying around this thing. But how would we answer this ridiculous question? Whatever makes sense. But for me, I have to talk it out every single time. But I'm thinking 2/15ths plus 2/15ths plus 2/15ths, so many amount of times has to equal 480. And when I talk it out, I realize, oh, I can convert this to 2/15ths times something equals 480. This would be 1 time around. This would be 1 time around. This would be 1 time around. So how many times around till you get to 480? And then I can just answer this with the calculator. 480 times 15, divide by 2. Hope you like the Ferris wheel. This doesn't seem very, I think I had a typo somewhere, but we're going to let it go. And the answer to the question is 3,600 times. This was a first date that turned into a marriage, a divorce, a marriage again, and 3 children. And they still, yeah. Before they even got off, this all happened. Are you hungry? By the way, 2/15ths of a second, like, here, eat. I don't even want to know how fast this thing's going. Yeah, that's right. I definitely have a number wrong here somewhere. I don't think I meant 8 minutes, but that's okay. Or maybe there's something I typed wrong. I usually check, not always, but I usually check for real, like kind of realistic values. I didn't with this one because I was like, yeah, that's the, yeah, maybe. Even then, though, the thing's going around in 2/15ths of a second. So it's not even 1 second you're going around this thing. Like that's, whoa. I don't even know if I want to answer this last question, but we will. This thing is so fast, faster than the speed of light. What is the linear speed? All right, so we're going to end here. What is linear speed? So the idea, before we answer this question, the theory is this. If it wasn't obnoxious, this is going around as a simple example. Say the distance around this circle, called circumference, we'll keep it really nice. Let's just say it was like 12 miles. So you have like this 12-mile wide circle. And this cart, this wheel, whatever, this spot, this seat on a Ferris wheel goes around in 1 hour. Well, the answer is, well, there's actually 2 answers. There's something called angular speed, which we're not going to calculate. But it says if you were to take this this circle and like just flatten it out so it laid on the earth as a flat object, then so you have a circle, imagine a string, and then you cut the string and you lay the string out. How long would that string be? 12 miles. And if you start here and end here in an hour, what's the speed? What's the linear speed we call that? It would be 12 miles per hour, because that's how long it would take from here to here on that line. So basically, bottom line is this: we need their circumference and we divide it by the time it takes to go around. What do you think what do you think the radius of this Ferris wheel is? Now, there's its graph. Right? This length right here is called diameter, and half of it would be radius. So, given what we know, particularly parts A and B, what's that distance? What's the diameter?
160.
I heard 90, heard 160. Do you want to defend your 90? It's a midline. Do you want to defend 160?
Or 170. Because at one point, the back part's going to be at the bottom, and by the time the other
Which
part gets
is
to the bottom,
10.
and by the-
And then, so like my feet are on ground level. This pen is 5 feet, not quite, but just closer to 6 feet above ground level. I'm not 5, I'm not 6. But then it's going to rotate around. And then I tell you it's at 16 feet. What's the distance from 6 feet to 16 feet? 10, right? That would be the diameter of the circle. Do you get it? Like if I could go up there to 16, from 6 to 16, that would be 10. So the same argument is, if this is at 10 and that's 170 directly above it, then what's the distance connecting them? 160. That would be the diameter of the circle. That's 10. That's 170. That has to be 160. Circumference. So another thing to now recognize is to find the linear speed, it's circumference divided by time. I already sold that story to you. But one last time. Take a piece of string. Boom. If it was whatever length and it took you an hour to go around it, if you cut that string and laid it on a flat line, you would start here and end here in an hour. That distance is your linear speed. So that distance was the circumference, and we're dividing it by the amount of time it took to go over that. So that's a must know. Secondly, though, pay attention to units. That was in feet. Says it in the problem. Something about the Ferris wheel was in feet, and the time to complete was in seconds. So our unit here, whatever this comes out to be, 160 divided by 215, is feet per second. Again, I'm really afraid to see how fast this thing's going. But if it's faster than the speed of light, I'm just gonna blame it on the rash. Yeah, the rash. Did anyone actually see it in the video? Does anyone want to see it? Close your eyes if you want to see it. It's pretty bad. But it's not contagious. Oh, it's bad today. Close your eyes. You don't want to see it. Oh. That scared the crap out of me. Yeah, I woke up, I'm like, how did I burn myself? I'm like, I don't remember burning myself. Go to school, wash my hands, things like a rap mile in it. I'm like, okay, go, like, freak out. Like, I'm like, what's going on here? But it didn't hurt. It's sore today only because it's the first day. Like yesterday, it started like peeling. So it's been checking with the doctor. And he's like, yep, exactly what I thought was going to happen. But I'm like, what is it? It's like eczema. I'm like, well, what is it? I don't know. I'm like, all right, good. He's like, you're all set. But just more scary than anything. I had a friend who had meningitis way back then, and just, that was a very serious thing. So I'm like, yeah. So freaked me out, and I'm like, yep, class is canceled, and I'm dying. No, I'm not. Yeah, I'm going to get a will. Life is over. It's nice knowing you. Hopefully you get a good professor. Sorry for everything else. All right, let's end this up. Here's where we are, 1,200 feet per second. And notice this says miles per hour. So this is more unit conversion. 1,200 feet per second. I'm going to get rid of seconds by multiplying it in the numerator and converting it to minutes, because I know 1 minute has 60 seconds. Then these would cancel out, but I'm now going to get rid of minutes and go to hours, because I know 1 hour has 60 minutes. And so now I'm left with the correct unit of time. So this answer, if I did nothing else, would be how fast it's going in feet per hour, but we want miles per hour. So we're going to take this unit of feet and multiply feet in the denominator and convert to miles. And I did tell you that 1 mile was 5,280. So a little bit of science here. I've mentioned that before when we converted degrees to radians, like unit analysis type thing here. It does come up in the homework. Very similar question. But at the end of the day, just to be clear, how I did it, if I started in seconds, you bring it in the numerator, convert it to something you know. Seconds to minutes is something I know. But I don't want minutes, so get rid of minutes, go to hours. Ultimately, now hours is in the denominator. Feet, we write it down in the denominator so that it cancels out with up here in the numerator, and we were given the conversion from miles to feet. 1,200 times 60 divided by 5,280. I'm so curious. 1,200 times 60 divided by 5,280. How fast is this Ferris wheel going in miles per hour? 818 miles per hour. That's faster than what the speed the plane takes off. That is a Ferris wheel of doom. No. Actually, that one might be fun. That one I actually might go on. That might be the only thing. You know what? That sounds fun. Exam 3. Anything I've said before this, I apologize. It started like a week or two ago when I sent out, oh man, the wrong date, because I thought I got freaked out with the schedule. Exam 3 is next class. It starts with Well, if you go back to Blackboard really quick, if you just give me a minute. And I'm going to send out something 100% tonight so it's officially clear what exactly is on there, but I'm doing it right now too. But I'll send it out in email form just in case someone's not here or you missed it. Weekly content video says right here, week 7. Exam 3 content starts here. Right triangle trig. So you need to know the Pythagorean theorem, sine, cosine, tangent, and their reciprocals. Questions that you used a calculator to like find the height of a tree or the base of a building if you were looking up at something. So something called angle of elevation and angle of depressions. Know the 30, 60, 90, the 45, 45, 90 triangle. Like you should be able to draw a sketch of those and use them if someone was like, hey, what's sine of 30? What's cosine of 45? Those common values. But actually, I'll come back to that because if you know the unit circle, you can also get those values too. But that's how it started, okay? Week 8. I kind of went over the same thing here. These identities you can ignore. I'll write that in the email too, right? But it's not going to be on the test. We went over them. So that way, if you hear identities in calculus, you did cover them and you'll see how they're used, but I won't assess them. But definitely like angle of elevation. And then definitely know what a radian is. The definition of a radian is arc length divided by radius. And there were some questions in homework from there. Be able to convert degrees to radians using that formula and vice versa. Know how to sketch an angle of rotation. So for instance, I would say sketch a negative 600 degree angle. You would sketch a clockwise rotation more than one time around. You would know what the reference angle is. You could say an angle that's coterminal to it by adding 360 or subtracting 360. And if it was in radians, you would add or subtract 2 pi. Know the common landmark angles, but that all really built up to the unit circle. So I'm going to give you a blank unit circle and ask you to complete it in under 10 minutes. I collect that at the 10-minute mark. If you finish it before then you get the rest of the exam. So the first question is a blank unit circle. I'll tell you that right now. Put your name, here's a blank unit circle, complete it. It's like somewhere between 5 and 8% of the exam. So if you don't know it, you don't know it, but they take 5 points off your test. So, and you should be able to complete it quickly. That means under 10 minutes. At the 10-minute mark, I'm taking it because it's not worth any more time. You got to get to the other stuff. But then be able to use a unit circle. So I do give a completed unit circle after, like you'll have it afterwards. And that way you can answer other questions that may come up. So knowing it by heart is part of the grade. And if you don't know it, then you get a little penalized, but you can still answer other questions on the test with the unit circle, right? So is everyone clear about that? You still should know it by heart. You should know it by the heart for the final exam as well. But if you don't know it, you're not like you're penalized, all right? But it's not that you can't pass this class. And then like just know like the formal definition of sine is y over r, cosine is x over r, tangent is y over x, and those reciprocal functions. And then the last lesson, which I wasn't here for, but was videoed, like the graphs of sinusoids. Basically, we addressed it tonight, but if you didn't watch it yet, tonight probably felt a little bit weird because I assumed everyone did. But in it, I kind of just go through it in amplitude, period, phase shift, and midline r, and how to find the values given an equation. And tonight, we just did the reverse of that, kind of given characteristics or given a graph, write the equation. So previously, you had an equation, state the characteristics. Now, given characteristics, write the equation was tonight's lesson. And that's it. There's no additional stuff from previous exams because I said that on day 1. There was a mishap few weeks ago. All good. It's only on what I just covered then. I'll see you guys on Wednesday on time. Thank you.
Would you go back to break that conversion down?
Which one?
The minutes to the, I mean, the seconds to the last thing you're, yeah, right there.